So it's still raining here in North Carolina, and when it's raining, I'm not working on Casper, unfortunately. But what can we do? I'm over here at DV's, and I thought it would be a good chance to do some work on Project Mission Impossible. Yeah, I know, the lowly 318 that we're trying to make at least one horsepower per cubic inch. Looks like we're going to have an uphill battle. So the first order of business is the most restrictive part of this build by bar none. It's the carburetor. The carburetor is going to be a huge factor in this deal. As you can see, this is what we're starting out with. This is a Carter BBD carburetor 2-barrel. I have to give a huge shout out to Just Mopar Joe for sending me this so that we could get to work on it. Now this is just going to be a mock-up carburetor so that we can do some testing on it. As you can see, we had to cut the throttle shaft off right there to fit our little flow plate. But when we first got this thing was nasty. So I'm going to tell you how we go about cleaning these things. So the carburetor looks a lot better than what we started out with. This thing was all grungy when we first got it. And in today's time, finding good carburetor cleaner is pretty much next to impossible. The EPA's come down on carburetor cleaner, and instead of going and spending good money on carburetor cleaner that you really don't know if it's going to do the job or not, you can go straight to Lowe's or Home Depot and pick up this paint stripper. And this stuff worked really well. Put it in the bowl here, make sure you use gloves, brush, and about 30 minutes of elbow grease on this thing. Well, not really elbow grease, just wiping it down. It come out looking like this. So, little cheap tip of the day, paint stripper works really good on carburetors. The first order of business we got to do to get this thing set up on the flow bench is we've got to find a way to adapt. Yeah, the flow bench. We've got to adapt this carburetor to fit. And this right here is what we're looking at. This is what we typically use for a 4-barrel deal. So we just modified it with some cheap duct tape. It'll serve the purpose as a gasket also. And then we're going to mount the carburetor on here, open the throttle blades. And while I'm doing that, DV is going to record the data here. And he's already said it's going to make, what, 220 CFM, something like that?
I guessed about 220, yeah.
I don't know. It's a 2-barrel Carter. I mean, come on, it can't be much. So
I hope I'm wrong and it flows 650 CFM.
Yeah, I doubt that. But yeah, the thing about it is, this is going to be interesting. Now, one thing to note, we're going to flow test this as a 4-barrel carburetor. We're going to do it at 1.5 inches. And because that's what most people relate to with CFM ratings. Unless you're like a restrictor class racer, you have to use a 2-barrel. Yeah, we're just doing this for commonality so people can relate to it. And this will give us an idea just how much of a stranglehold this is going to be on our little 318. Poor thing. I can honestly say this is a first for me. I've never flowed a 2-barrel carburetor. I've never.
Doesn't get you excited, does it?
Not really, but what's exciting is to see what we can get out of it, I guess.
Yeah. We are going to be hard pushed to get it to 275.
Oh, I know.
Right. Now, I know a 390 carb, you can make 400 horsepower.
Yeah.
For a cup car.
Right.
Right. But now for a
But the engine underneath it's a lot different.
Yeah.
Let's see what this thing does.
Right, okay, let's go for it. We're recording, so electronics.
interesting. First time I've ever flowed a 2-barrel carburetor, and David was estimating that it was going to be somewhere in the 220 range. I had no idea, but as you can see by the footage there, it was pretty decent. Now, one thing I've got to point out about all of that is first thing when it comes to flow bench testing, you have to check for leakage to see how much you've got in leakage in the fixture itself to make sure that your data points are correct. So when we flowed this, we got about 15 CFM of leakage because this is just rude and crude plate here, so nothing scientific. But when you subtract that from the 270 odd CFM that we seen, it's going to be around 255, 256 CFM. So that gives you an idea what we're working with, which is not much. We can already see now that this is going to be an uphill battle. So we've got a lot of work to do to this little gem right here, just so that we can have a shot at making our goal.
Well, Andy, one of the things that's obvious in here is they didn't spare crank strength.
No.
Right? This is a stout crank.
It is. I mean, this thing is beefy. I mean,
Yep.
for it to be in a passenger car 318, even though it's a cast crank, it's pretty heavy, or at least
Yeah.
my back says it's heavy.
Yeah. Well, Andy weighed it a little earlier on. It was 55 pounds. It's way heavier than a Chevy crank or a Ford crank. We checked it out, and it's got a pretty lot of wear on
Oh,
it,
yeah.
hasn't it?
It's going to have to be turned.
Yeah, we're going to have to grind the crank. So, since we've got to grind it, we're going to look into the possibility of stroking it. Now, we've got one other aspect we need to consider. This crank has got flat counterweights on the leading edges, right? It's got flat counterweights on all edges. And so, we've come up with a plan that can allow us to take off a considerable amount of metal here to knife edge it, and we'll show you what that is. Connecting rods.
So one of the things that Chrysler guys have always touted themselves with is their beefy connecting rods. These things are huge, and while you really can't get an idea of it when you're just looking at this, take this rod here. This is a small block 3 Chevy rod that David prepped, polished the beams on it. There is no comparison as to which one is stronger. This particular rod here would be good up to about 6,700 RPMs, around 500 horsepower. So if we can take off a ton of weight off this rod and do the typical polishing of the beam here, that means that we can put a lighter piston in the engine, which means our counterweights won't have to be as heavy, and all of that adds up to one thing: more horsepower. Is thinking outside the box like this is how we're going to have to do this.
Thinking outside the box, well, I don't know if it is for regular Chrysler owners, but it is for me because I've never worked on an engine like this that I can remember.
Right.
Right? The points that we looked at on the rockers are worth bringing up, because to start with, we've got to try and optimize the valve train with what we've got.
Yeah,
so
exactly
let's take
right.
a look at the rocker pattern on the end of the rocker and tell the folks
Okay.
what we plan for that.
Yeah, because we've got a lot of work to do there too. This is a typical stamped rocker that's used on a small block Mopar. Even the big block Mopars use the same style rocker. One of the benefits of it is it actually uses a shaft system instead of the bucket type deal, which comes from Ford, Chevrolet, you know the deal. But there's some interesting things that DV and I have been talking about with this particular setup for Project Mission Impossible, and there's some tricks as to how we're going to go about getting this valve train set up. So you want to talk about that?
Now what I want you to look at here is the wear pattern here, where we've created a pattern on the end of the rocker. Now this has got quite a lot of miles on it, and notice there's very little wear. Now what I want to point out is where that wear occurs on this radius here, right? Now it's probably set up for the least side thrust on the valve guides by the valve, right? So that geometrically, from the point of view of niceness, it operates right off the center of the valve and it pivots about the center of this radius here. But that's not the best for us. If you look at this here, you'll see that we could go further around that radius. And what that does, if we're contacting the valve there, right, that's further from the center here than it is if we contact it there. So by altering the height of our rocker and the push rod length, we can maximize the ratio on this, and I'm pretty sure we can get something like about a half a point more, maybe 3/4 of a point. So if this was 1.5, we can probably get 1.57 out of it, nearly 1.6, by careful adjustment of the height of the rocker and the length of the push rod. So get a high lift rocker.
That's right.
Right, now it's not much, but it isn't going to cost us anything. So it's free horsepower. We didn't have to buy rockers. Save money, but we've got the benefit. Okay, let's wind this thing up, Andy.
Yeah. So as you can see, we've been busy today. It's been raining outside. So this was a really good opportunity for us to do a little bit deeper dive in Project Mission Impossible. Like I said, this is just the very beginning stages, and we're going to work on this as time allows, because like in the live stream a while back, I said that David has a lot of obligations he's got to do. I still have to get Casper running, but at least we've got the ball rolling on this, and we can continue to do it in segments, so you'll see that throughout. What did we learn today, David?
We learned we've got a steep hill to climb.
That's putting it pretty mild.
I think that that's about the only total 100% certainty we've got.
Yeah. Yeah, the little 2-barrel Carter BBD, yeah, it is what it is, but we've got something to go off of now. Yeah. We've got measurable, tangible evidence of what we've got, and so
once we've worked on that on the bench and got the best flow out of it, we should be able to predict the horsepower that it will make.
Absolutely.
Fairly accurately.
Yeah.
Probably within 5 or 10 horsepower.
Yeah. So that's a good thing. And really the induction system, and we're having to build this as like it would be a restricted motor, like a circle track restricted 2-barrel motor, a restrictor plate motor with a lot of compression, a lot of head flow, a lot more than we would normally need. So until next time, this is Andy from Unity Motorsports Garage. This is the one and only David Vizard. We will catch you.
Actually, Andy, that's not true.
No, there is another guy.
There's another one in Charlotte.
Crazy.
And I've also got a cousin up at the Montreal Gazette or the Montreal Times. Same name. And he's got davidvizard.com. davidvizard@gmail.com. Right. So and he got that about 2 days before I applied for it. So
crazy. We will catch you later.